Now part third of the chapter first, that is number system. I have already discussed two part first and second. Now this is the part third. In part first, I have explained all the definitions of the numbers. In part second, how will you find out a rational number between two rational numbers? Now part third, the decimal representation of the real numbers. The decimal representation of real numbers are of three types. First, when the remainder is zero. When the remainder is zero, by taking an example, 2 by 5, you will see when you will divide 2 by 5, you will get 0.4 and there will be no remainder. Here remainder is 0. Here division terminates. So this is a terminating decimal. And this decimal is a terminating decimal, and this type of numbers are rational numbers. So the second type, when the remainder is not zero, when the remainder is not zero, there are two types in this. There are two conditions in this representation. First, when the decimal representation is non-terminating repeating, yani continuously a number is repeating. For example, For example, 1 by 3, 0.333 and so on. This is a non-terminating and repeating decimal. And you can stop this number here, or you can stop this number here, or you can stop this number here by putting bar on the head of this number. This is the condition. You can stop the repeating. Repetition can be stopped by putting the bar on the head of that number, anywhere as you like. Just you have seen in the example. This is the repeating any condition, any non-terminating repeating condition. Other example, 10 by 3. This is 3.3, 3 and so on. And it can be written as 3.3 bar or 3.33 bar or 3.33. You can stop it here also. So repeating can be stopped anywhere as you like. So third condition, non-terminating, non-repeating. In this case, when you divide a number, you will not get anywhere repeating number. New numbers will come again and again. So there will be no end of the division. So this type of numbers are called non-terminating, non-repeating. An example of these numbers is root 2, root 3, pi, etc. So these numbers are called irrational numbers. There are three types of decimal representation. Terminating, these numbers are called rational numbers. Non-terminating repeating, these numbers are called rational numbers. Third, non-terminating and non-repeating, these numbers are called irrational numbers. This is the decimal representation. You have to note it. When you find out anywhere this type of representation, you can say this number is a rational or this number is not a rational. So in this part third, one thing more, very important. I'm going to tell you that how the decimal representation can be converted into rational number. So I'm taking example, conversion of decimal numbers into rational numbers. First example, 0.5 bar. You can convert this rational number, decimal, this is a rational number, but it is in the form of rational, in the form of decimal, and we want to find out the rational form. So it can be written as integral part plus decimal digits upon equal number of 9, equal नंबर, शॉर्ट में लिखते हैं इक्वल नंबर ऑफ 9. Here you will see that this number 0, integral part is 0 and decimal part is 5 digit and equal number of decimal digit 9. This is the 5 by 9 rational number. Take another example. 0.35 bar. Second example. Now integral part is 0 and decimal part is 3, 5 and equal number of 9, double 9. And this is the number 35 upon 9. This is the rational number. Again, I am taking next example. Third, 4.75. This will be integral part is 4 plus and decimal part is 75. Decimal part is 754 and equal number of 9 is equal to, I have increased one more because in first example, in second example, we have taken 2 decimal. Now I write this example again of 3 decimals. Now this is, and you can add by LCM these numbers, you will get rational numbers. By adding these two numbers, by taking LCM, you will get the rational number. This number will be equal to of that number. This is decimal representation and that will be the rational number. So one example I am taking more in which method is somewhat different from this first method. Now this is the example, 0.3 bar. Let x is equal to 0.3 bar. This is first. And x is equal to 0.33 bar. We can write this. I have told you that decimal, this repetition can be stopped anywhere. I want to stop it here. I want to stop it on second position. So this is the condition. We can write this. We can write this number equal to this. Now multiply by, this is second, multiply second by 10, 10x is equal to 3.3 bar. This is third. And write down first x is equal to 3, x is equal to 0.3 bar. This is the first. By subtracting both the numbers, this cancel with this, and 9x is equal to 3. And 9x is equal to 3 and x is equal to 1 by 3. X is equal to 3 by 9 and x is equal to 1 by 3. And x is equal to, if you want to check the answer, again divide 1 by 3, you will get 0.33 and so on. This is the decimal representation and this is the rational number. So decimal representation can be converted into rational and rational number can be converted into decimal number. I want to take one more example of this. This is a typical example, 0.47 bar. Let x is equal to 0.47 bar. Now 10x is equal to 4.7 bar. Now it can be written as 10x is equal to 4.77 bar. Now multiply this. This is the first. This is the first. And multiply multiply 2 by 10. 100x is equal to 4.77 bar. No. 47.7 bar. This is the third. Now 100x is equal to 477 bar or 10x is equal to 4.7 bar. This is the third and this is the first. By subtracting third from first, you will get 90x is equal to 43. And x is equal to 43 by 90. This is the required number. This is the required answer. So you have to take this. So this example, this is the number. I take it, I let it x is equal to this and multiply by 10. Multiplying by 10, this number, you will get 10x is equal to 4.7 bar. Now again, I am writing this number again, 10x is equal to 4.77 bar, multiply second by 10 again, 100x is equal to 47.7 bar. And by subtracting third from first from third, you will get 90x is equal to 43 and x is equal to 43 upon 90. This is the condition. Or you can take more example in this way. So this second method is very important from the examination point of view, and note it when you will get any question from this chapter in terminal examination or in the annual examination, you will get one question 100% from part third. You have to convert a decimal representation into a rational representation, rational number. So this is very important, and you can do more questions from your textbook. Thank you.